Identify the shapes that make up the faces of each solid. Determine the number of each shape and whether the shapes are identical. So for example, in a hexagonal pyramid, we have a hexagon base, and there is one hexagon. And then there are 6 triangles. Now, if it was specific and it told us it was a regular hexagon, then we would be able to say that the triangles may be identical. However, it doesn't specify that this hexagon is a regular hexagon. So we might have a longer side and then a shorter side. And so then the triangles that are coming off of it are going to have different size bases. So they don't necessarily need to be identical. These figures all show the same triangular prism from different perspectives. What are the shapes of the bases? We have a triangle on the top and on the bottom, and we have a rectangle around the sides. So there are 2 triangles, which are identical triangles, and 3 rectangles. The 2 triangles are identical, but we don't know that the rectangles are identical, given that this is an equilateral triangle. If it is an equilateral triangle, then all 3 sides around the triangle would be the same. So the dimensions of the rectangle would also be the same. Here we have several figures that represent cutouts. Which cutouts do you think could be folded into a triangular prism? Well, we just mentioned that it should have 3 rectangles and 2 triangles. This one only has 2 rectangles, so C cannot be formed into a triangular prism. This one in D can also not be folded into a triangular prism because the triangles should be on the sides. Otherwise, we're going to be able to connect the points of the triangle, but we'll have open gaps on the sides. If we folded this one up in this direction, this piece could also be folded around to meet this piece. So B and A could both be folded to form a triangular prism. Determine which 2-dimensional figure can be folded to form each solid in the table. Then name the solid. Looking at this first solid, I see that the base has 1, 2, 3, 4, 5 edges, and then several triangles coming off of it. Here is a shape with 5 edges, but these would be connected by rectangles. So C is going to form this first solid. A 5-sided polygon is called a pentagon, and since it's connected by triangles, we're going to call it a pyramid. The next solid also has a pentagon, but it's connected by rectangles. So that one will be called a pentagonal prism. Pyramids get connected by triangles. Prisms are connected by rectangles. And that was figure E. This next one has 2 triangles and 3 rectangles. Since the base is a triangle, we're going to call this a triangular prism because the top and bottom are connected by rectangles. This here in figure A has 2 triangles and 3 rectangles. This is also a prism, and the base of this prism is a rectangle, so this is called a rectangular prism. We have a rectangle on the top and bottom, and then 4 around the middle. So we need 6 rectangles. This one has rectangles, and this one has squares. This is more rectangular, and this one is more square. So this one is going to be F. Since the bottom and the top are connected with triangles, this one is called a pyramid. And the base is a triangle, so this is a triangular pyramid. There's a triangle on the bottom and 3 triangles in the middle, which would be figure D. You can think of this as a square prism, but a square prism has a fancy name, and it is called a cube. And that one is formed in figure B. The net of a solid is formed when the surface of the solid is cut along enough edges so that the faces can be placed in one plane to form a connected two-dimensional figure. That's just a fancy way of saying if we slice along the edges and lay it flat, that's the way we would get a net. We can think of a net as showing what a solid looks like when we cut along some of the edges of the solid and lay it flat. Some of the cutouts we talked about in the opening activity are examples of nets. Let's look at how we would unfold this one. Notice that there are 2 faces on opposite ends here. Let's look at it from another perspective. Which figure is a net of this right rectangular prism? We have a top and a bottom, which makes 2 faces. So 2 small rectangles. And then we have a back and a front and a left and a right side for 6 total faces. A has 1, 2, 3, 4, 5. So that is not a net of this figure. If we were to cut out figure B and fold it up, would it create a net of this figure? Well, we have 1, 2, 3, 4, 5, 6 faces, so there's the correct number of faces. This one also has 1, 2, 3, 4, 5, 6. And this one also has 6. However, you may notice that these 2 pieces out here are on the same side. We would need one of them to be over here in order for it to fold up for the other end. So C is not a net. If we were to fold these pieces together, these 2 would overlap and we'd have an open section here. This one is also not a net of this figure. We would have an overlapping part from these pieces here. But D does create a net of this solid. Here's an example of a triangular prism turning into its net. There are 2 triangles and 3 rectangles. Here is a pyramid. Circle the nets of the right triangular prism. The triangles need to be on opposite ends of the rectangles for it to form the top and the bottom. Here, this one has it on the top in both sections, so the bottom piece would still be open, which means it does not create a triangular prism. This one has too many triangles and not enough rectangles. This one will work. This one will work. These two are a little different. Try to visualize folding them up in your brain, or try cutting it out and folding it with paper. Would these two form the triangular prism? Yes. And yes. Which figure is a net of the square pyramid? There is 1 square on the bottom and 4 triangles around here. B has too many squares. C does not have any squares. A looks like the figure we saw in the model that unfolded. Here, if we were to try and fold this piece up, this piece would overlap or touch this part here, and it would not form the square pyramid. The nets form either prisms or pyramids. Circle the nets that form pyramids. When we were filling in our table, I mentioned that pyramids are connected by triangles, and prisms, the top and the bottom, are connected by rectangles. If we were to fold this piece up, the top and the bottom would be connected by rectangles, so this one is a prism. But here, these 4 triangles would fold and come to a point, so that one does form a pyramid. This triangle is going to connect over here, and this one will be on this side, so it also forms a pyramid. This one is only made of triangles, and it's going to form a triangular pyramid, along with this one, and this one will be a square pyramid.